just do a quick review on how to graph points here. It should be pretty easy. Everybody's pretty smart here. Of course, the ordered pair tells you the first number is your x coordinate, and that tells you which way to go, left or right of the origin. And your second number tells you your y coordinate, which tells you how much do you go up or down. And for instance, to plot 10, 15, you would go start at the origin, go 10 to the right, 15 up, plot. If I want to go 0, -5, 0 means I don't go left or right. -5 means I'm going 5 down. Point C, -10, 0, that means I go 10 to the left from the origin and I don't go up or down. So that's where I get my C. Okay, so why don't you try the following examples just to refresh your memory. I'll give you a second to complete it. Okay, what is point D? Who can tell me the coordinates? -2 what? -4. Point E? 0, 2. F? 6, 0. G? 4, -4. Very good. Okay, so the next one. We're going 12, -8, and then we plot and put P there. 0, 4, we put Q there. -8, 8, we're putting R there. 8, 0 is S, and -4, -12 right there is T. So did everybody get those in that spot? Okay, so now we're going to do this lab. So you're working with a partner. You're going to record all the measurements in the table below. So the first thing you have to do is measure how long the rope is with a ruler. That's why I gave you 2 rulers, because it might be longer than that, so that you can actually, actually you might need 3 rulers. I don't have a 1.6, sorry. So anyways, you're going to measure it, then you're going to tie a knot, and then measure it, then tie another, and measure it. You see what to do. Record your results. Try to make all the knots the same size and tightness, okay? Once you're done, you are going to plot this on the graph here. Okay, I'll give you some time. So who would like to be the... No, just tell me out loud. For 0, what did you get? 78.5, okay. 73, 67, 62.5, 57.5, and 52. So now I look at my data, and I need to have basically a range of around 50 to 80, right? So that's how I'm going to start with my broken graph. If I start at, say, 50 here, can I get all the way to 80? 55, 60, 65, 70, 75, 80? Yeah, that works. Do you see how I came up with my scale? Yes? And I didn't put every one, because otherwise it gets messy, right? Okay? So now I'm going to plot 0, 78.5. I don't know. That's 75, so say about there. And then 1 is 73 right there. 2 is 67, so right there. 3 is 62.5. Look at that, how beautiful this works out, hey? Number 4 is 57.5, and number 5 is 52. So I have 1 square equal 5 centimeters. Okay, so does it make sense to join the points? Why, did you get the same measurements? No. Okay, no, everybody's going to have different data, for sure, for sure. But it's going to look like this, similar, going down, of course. Yeah. Okay, so question for you, does it make sense to join the points? It looks like a line. I want to make a line. Do I make a line? Yeah. No. Why? You can't have partial knots, right? So Like, does it make sense to have 1.2 knots? You can't have that. That's what it represents when we join it. I hope everybody understands that. When I join these points together, that represents that I can have anything in between there. So you can't join it together if it doesn't make sense that you can have, so you can't have, oh, let me just erase this. Can't have partial knots. Okay, does anybody know what that's called when the data cannot be connected together? We learned this in grade 9. Starts with a D. Discrete data. Discrete data. That means you cannot connect them together. Does anybody know when I connect them together what that's called? Starts with a C. Continuous data. That means it's continuous. I don't lift my pencil, right? Okay, so let's go on to part C. Is the relation between the number of knots and the length, is the relation between the number of knots and the length of a rope a function? Yes. How do you know? Oh, I like your answer. For every input, which is the number of knots, right? There is only one output, which is the length. What is the domain? So your domain is going to be slightly different than mine, but the domain is going to be the number. Oh, actually, I guess it won't be for the domain, right? It'll be the length that'll be different. So 0, 1, 2, 3, 4, 5. Yes? Okay, for my range will be different than yours because you measured differently or you tied your knots differently, whatever you want to say. Okay, so that, I'm going to go from least to greatest, so I'm going to go 52, 57.5, 62.5, whatever yours are for your list, right? 67, 73, and 78.5. Okay, any questions there? No? Okay, let's keep going. Could the graph be extended to the right? Yes. Explain. You could continue to add up knots. Yes. Yes. You could continue to add knots. And you can actually guess it. So can it be extended to the right? No. Actually, there is a, I was going to say, I'm sorry? Yeah. If the rope was longer. Let's look at the left of the graph, though. That would be negative knots on the left of it. Do you see what I'm saying? Now, you might say, oh, well, at some point, did you ever do in grade 9 where you folded paper and you could see how many folds you could get? At some point, there's a limit to how many folds you can do. Same thing with your rope. At some point, you can only tie so many knots on that rope. But we're not really looking that far into that. We'll see. Okay, so you can't have negative knots. Okay, would you join points on a graph that represent each relation below? Circle your choice. So I'm going to give you a second to look at these, and I want you to circle yes or no, and we'll discuss it in a second, okay? So the relation between mass, like how much you weigh, and age of the baby. Can you join the dots? Yeah, oh, for sure. You can have partial ages and you know, partial mass. Okay, the relation between number of cones sold and outside temperature. So that would be no. Why is it a no? You can't have partial ice cream cones. Okay. The relation between the volume of gas in a car and the distance traveled. Yes. Yeah. The relation between the outside temperature and the time of day. Yes, yeah. The relation between the number of t-shirts sold and the profit. No. Okay, so do you get when you join it, when you don't? Because that will be part of your quizzes and tests now. Like you're going to plot data. Do you join them or not, right? Okay, moving on. This is a table of that shows the number of cars in a school parking lot during the day. Choose a scale. And so they're kind of helping you with the scale thing here. The greatest number of cars was what? 35. And the least amount was 0. So if I were to look on this and see how much spaces I have, what do you think is the best thing to go for each square? Huh? 5, yeah. So then that would be 10, 20, 30, right? Yes? Okay, so now we're going to plot it. So 0 at 7 a.m. Yes? 8 a.m. is 20. 9 a.m. is 35. 10 is 35. 11 a.m. is 35. 12 is 10. Wonder what happened at noon there. Yeah, looks like it, eh? Must be a high school because elementary the cars wouldn't leave, I'm sure. 2 p.m. is 30. 3 p.m. is 30. 4 p.m. is 5. So is that what you got there? So would I actually connect the dots here? No. No, why not? You can't have partial cars. Can't have partial cars. Is the relation a function? Ooh. Yeah, if 9 goes in, 35 comes out. If 10 goes in, like it's not a doubt. I think you're confused because there's like a bunch of 35s in a row. But that's okay if they have the same output. It's just for every input there's not. So if you had an extra 9 o'clock, right, going to whatever, then you're not certain at 9 o'clock, is it going to be 35 or is it 30 or whatever. That's the true test, right, if it's a function or not, is there any doubt when it's 9 o'clock how many cars was there? So yes, this is a function. For every time input, there was, oh sorry, was the time the input? Yeah, the time was the input. There was only one output number of cars. What was the domain? Yeah, 7. I gotta have my chart here. 7, 8, 9, 10. 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 p.m., 1 p.m., 2 p.m., 3 p.m. Did it go up to 4? Yeah. Okay. So this is why it's important when you do your range, you should do it from least to greatest, because then you're not listing it more than once. So my range was 0. What was the next one? Nope, 5. Was there a, there was a 10. Is there a 15? No, the next one would be 20. Was there a 25? Yeah. Was there a 30? Yeah. And there was a 35, right? Okay, so we do not list it more than once, okay? And that's why it's important to go least to greatest, so then you don't double up on anything there. And you need to have these fancy brackets, right? Notation marks will be taken off if you're not doing it properly, right? Okay, do your best. Okay, we're going to graph this data. The greatest water was 180. So we have to make it going from 0 to 180. So there's 2, 4, 6, 8, 10, 12. So what do you think we should do? 15s? Oh. What, 10? Oh, yeah, because it... 15. So, okay, 30, 60, 90, 120, 150, 180. I like the person that said 15. Very good. That was a great scale. Okay, so now we're going to plot the points there. So I'll give you a second to do that. So what do you think? Does it make sense to join these points? Why does it make sense to join the points? Yeah, the height of the water can vary, right? The time and the height can, or is continuous. That's probably the best answer, right? So it's kind of like a little curvy. Yeah? Is it a function? Mm-hmm. And what's the canned answer? For every input, there is only one output. I hope you get that right on the test.